Find the area of the surface defined by rotating the function y is equal to 1/4 x squared minus 1/2 ln x about the y-axis on the interval from 1 to 2. Okay, so to find the surface area, we need to take the integral going from a to b, or just our bounds, of 2 pi, because we're doing the surface of revolution, x ds. And we chose to use x here because we're going about the y-axis. If the question here said the x-axis, we would use a to b of 2 pi y ds. But this one, the y-axis, so we chose the x. And also a special thing to note here is that our ds is represented by our arc length of that section of our function. And arc length, remember, is going to be equal to 1 plus the derivative of our function squared. And for problems like this where we're finding surface area, I would recommend our first step to just finding ds. So let's go about that. So the derivative of our function, let's spread it out again right here, is going to be equal to 1/4 x squared minus 1/2 ln x. And to find our derivative, let's just take this power rule for our first value of 1/4 x squared. We'll have 2/4 times x, and we don't have to write the 1. It's implied. And then we'll have 1/2, we'll leave this constant out. And the derivative of ln x is just going to be 1/x. So we'll leave off with 1/2 over 1 times x. And simplifying this, we'll have 1/2 x minus 1/2x for our derivative of our function. So now let's just make some room, and we'll begin solving the inside of that radical. Now that we found the derivative, let's just do the inside of our rational. So we'll have 1 plus, we'll do our parentheses, 1/2 x minus 1/2 x, and the x is in the denominator. And we'll have this squared. So we can just simplify this now. Now we just need to get rid of the squared with the parentheses, and we can just remember the formula errors. So we just need to get rid of the squared in the parentheses, and we could just remember the formula a squared minus 2ab plus b squared. It's tempting to just apply the square root to both of these, but if you remember the exponents, they don't distribute the way constants do. They have their own set of rules. So when we write it just like this squared, we're actually representing it like this. So that's why we have to use this formula up here. So if we use that, we'll have 1/2 x squared is just going to be 1/4x squared minus 2 times a times b. So let's have a times b. We'll have x over 2 times 1/2x. We can see that these x's will simplify, and we're left off with 1/4. But times 2 is just going to leave us off with 1/2. So we'll have minus 1/2. Let's get rid of this. And then plus b squared is just going to equal to 1/4x squared in the denominator. And this actually should be on the top, x squared. And if we simplify this, we'll have 1/4 x squared minus 1/2 plus 1/4x squared. And now if we add this to 1, we'll have 1 plus 1/4x squared minus the half plus the 1/4x squared. that negative half will just become a positive half if we add that 1. So combining like terms. Plus 1/2. There we go. Plus 1 over 4x squared. But now we can see something special with this new expression that we have. We can actually just factor that out. And it'll work out eventually with our big square root, with our radical. So 1/4 x squared plus 1/2 plus 1/4 x squared in the denominator, we can express that as 1/2 x plus 1 over 2x squared. And now if we put that inside of our radical, we can notice that our squared on the parentheses is going to cancel out with the radical that we have. And now for our ds, we can just notice that it's 1/2 x plus 1 over 2x. So now that we have all of that work finished, we can finally start evaluating our integral. We can do the actual calculus part. So our a value is going to be from 1, and our b is going to be to 2. So we'll set up our integral from going from 1 to 2 of 2 pi times x all times the ds value that we just got. So ds is equal to 1/2 x plus 1 over 2x. And then dx. So we can probably leave out our 2 pi since that's just a constant. So 2 pi going from 1 to 2 of x. And what we're going to do here now is just multiply our x out and simply evaluate the integral. So 2 pi x times 1/2 x is going to be equal to x squared over 2. And then let's write this out just so we can see it. We'll have x over 2x, and those x's will cancel. So we're just left off with 1/2 dx. And something that I noticed right now is we could take out our half. Both of these have a 1/2. So if we factor that out, we can just get rid of this 2 right here as well. So let's do that. So we'll have 2 pi times that 1/2 that we pulled out, going from 1 to 2, of x squared plus 1 dx. So using our power rule, x squared, when we take the integral of that, it's going to be equal to x cubed over 3. And then that 1 is just going to equal to x. Going from 1 to 2. And when we plug in our values, we're going to be left off with pi multiplied by 2 cubed over 3 plus 2. And then we subtract 1/3 plus 1. So just working this out, we will receive pi 2 cubed is equal to 8, so we'll have 8/3 plus 2 minus 1/3 minus 1. Let's see, changing everything, we'll have pi times 10/3, and that is our surface area.